Hi, everyone. Welcome to Connecticut River Conservancy's live stream. We're in season 3, and this is episode 4. You're in my garden. Sustainable home gardening solutions for cleaner water. My name is Stacy Leonard. I'm the events coordinator here at CRC. I'm really intrigued to learn alongside all of you today how nitrogen impacts our rivers from the northern reaches of Vermont, New Hampshire, all the way to the Long Island Sound, how to reclaim our urine or pee cycle to fertilize our gardens, and how this is being done on a community scale at the Rich Earth Institute in Brattleboro, Vermont. Before I introduce our speakers, I'll just share our usual housekeeping details. We are recording this episode, and we'll have that posted within a day or two on our live stream webpage, as well as our YouTube channel. And I always share an email at the end of the day with those links and all list of all the resources and links that you hear today. So stay tuned for that. We really encourage your questions, and we're going to make time for Q&A at the end. So please use the chat to ask your questions anytime, and we'll answer as many as we have time for. And I'd like to just briefly let you know about our final 2 live streams that are coming up for the season. In 2 weeks, May 18th, we'll have one on hydrilla, the many-headed monster, what it is and how to fight it. And on June 15th, climate change along the Connecticut River. You can read the details on our live stream page and our events calendar. And again, those links will be shared. And we're trying something new this year called River Steward Rendezvous. And Kathy Erfer, who's one of our presenters today, will be sharing that on June 14th, discussing water quality standards, how rivers are assessed and graded. And we hope you can join us for any or all of those events. So let me introduce our speakers. First, from the Rich Earth Institute, we have Julia Kaviki. She coordinates Rich Earth's Home Gardening Education Program, Annual Urine Reclamation Summit, and Community Engagement. She received her BA in Environmental Studies from Skidmore College in 2018 and an MRes, if that's the right way to say it, in Human Geography from the University of Glasgow. In the past, her research has explored combined sewer overflows in Troy, New York, glass eels, community science, and the environmental humanities. Julia has been an avid pee cycler since joining the Institute in 2019. I'd like to become one of those too. And we also have, as usual, our wonderful river steward from Vermont, New Hampshire, Kathy Erfer, and she's been in this role since 2017. Prior to joining CRC, Kathy worked for Hackensack Riverkeeper in New Jersey and has worked on wastewater treatment projects. She lives in Brattleboro with her family. So I'm going to turn it over to Kathy to get us started. So thanks, everybody. Welcome. Thanks for being here from near and far, because this issue affects us wherever we are. Oh, I didn't intend that rhyme, but that was kind of fun. Bye for now.
Thanks so much, Stacy, and welcome everybody. Good early afternoon here. As we said, this is You're in My Garden, Sustainable Home Gardening Solutions to Reduce Nitrogen Impacts to Our Waters. And I wanted to start with a reflection on this picture. This is, there was a big tropical storm that came up the East Coast in 2011 and caused an incredible amount of damage very far upstream in Vermont and New Hampshire, a lot of erosion. And this is the sediment load that was coming out of the river, just shortly after that storm. And this is the mouth of the Connecticut River as it enters Long Island Sound. You can also see the storm, the Thames River there on the right of your screen. There, it's a darker color coming out of that. And so I don't know if those pollutants were more oil or things like that. But just as a place to start in thinking of the connection, where I am very far upstream in Vermont, and even though I'm so far upstream, the impacts that we can have as rivers flow south, right? So trying to make that connection is a big part of what we do as an organization, working really locally and making that connection out to the larger watershed. And so here you see essentially the Connecticut River watershed in its relationship to Long Island Sound. And you can see some of the smaller watersheds that also empty into Long Island Sound, and the impacts from our different watersheds can be very different. The Connecticut River, just as a little bit of background for those who may not know, it's a 410-mile river. It starts at the border of Canada, makes up the border between Vermont and New Hampshire, and I'm the river steward for that whole section, the northern section of the river there between Vermont and New Hampshire, and the watershed there. And it drains over 11,000 square miles. So it's a huge watershed. And as I said, we try to, in my work, I'm constantly trying to make a connection between local projects, what they do on the ground, and then the larger picture of the watershed. And we have all heard the phrase, death by 1,000 cuts. We know that that's how our water gets polluted. And so often when I'm thinking about solutions, it's really the healing by 1,000 little steps, right? And so we're really honored today to be able to be joined by the Rich Earth Institute and provide one of those cool solutions that these guys have come up with. So I'm going to provide a little bit of background before I pass this off to Julia, so we understand some basic concepts that are really important here. One is part of our focus is on the Long Island Sound because the Long Island Sound at this point is incredibly hypoxic and has been for many years. And so what you're seeing here is a little map showing the eutrophication, the results of eutrophication in the Long Island Sound. So there's been over many decades of pretty intense loading of nutrients into the sound, which has caused algae blooms. When that occurs, you get this huge growth of algae. The algae dies off. When it dies off, it uses the oxygen up in the water, and you then have hypoxia. And so this, from what you can see here, the western section of the sound has been hypoxic, meaning there's no dissolved oxygen, meaning things cannot live in that water for many, many years. And so we're trying to figure out how we solve this problem and bring life literally back to this area of the sound, along with many partners, obviously, including the EPA. So several years ago, there was a TMDL, which I will define, implemented to try to address this issue in the Long Island Sound. TMDL is short for total maximum daily load. And you could kind of think of it as a diet, right? So when I'm talking to school kids, I often speak about this in terms of like, if you ate too much sugar and you're putting on weight and your body's starting to feel unhealthy, the way you heal yourself is by eating fruits and vegetables and less sugar. And so the corollary here is, to a certain extent, the nutrients that have been entering the Long Island Sound are like the sugar, right? And we need to reduce that in order to help heal the water in the sound, and frankly, also in our river, right? And so the way you do that is a diet. And when you have a diet, you have a certain amount of things that you input and you try to ratchet that back, right? So TMDL is allocating and calculating amounts of nitrogen from different sources that may be entering the sound, and slowly trying to, from a regulatory perspective and a voluntary perspective and a project perspective, ratchet that nitrogen down. So there's less and less going into the sound. Now, this is focused on nitrogen. And I also want to talk about phosphorus, because both of these are nutrients. They enter our waters, but they end up affecting freshwater and saltwater slightly differently. And so from just a basic, human biological creature need, nitrogen and phosphorus are building blocks for cells, right? Like they're important for growth. And this is why when they function in water bodies as a way to grow algae and function well as a fertilizer. But where they come from is different. And so just a little bit of background here. Phosphorus is released mostly from rocks, right? So as you have an erosion cycle, the phosphorus comes out of the rocks. It can accumulate in soils. And we have taken that phosphorus, because it is important for organic life, and put it on agriculture lands, used it in detergent, right? So we have found ways to use phosphorus in things that benefit humans. once you get too much phosphorus on the land, if it's coming off into a water body, that's when we have the problem, right? So can be really useful in one situation. As it drains into water, can become a problem. So the important distinction here is that phosphorus is often the catalyst for plant growth in fresh waters. So you more often hear in lake systems and freshwater rivers, phosphorus being the thing that is focused on for a TMDL or for something that needs to be reduced. Similarly, you have nitrogen, right? Also needed by organisms. Nitrogen is available in the atmosphere. It gets fixed by certain plants. We know this from our gardening, right? Into soils and then can be used by plants. And similarly, nitrogen ends up in a lot of our industrial processes, right? So because we're human, it ends up in our own sewage streams as a, an effluent that comes out of wastewater treatment plants and septic systems, things like that. It comes into the ground and then washes off into the water just from deposition from atmospheric nitrogen. And then power plants, and it's also used as a fertilizer, right? So a bunch of different ways that nitrogen ends up on the land, and also if it runs off into the water can become a problem. But this is the catalyst for saltwater plant growth. So around coastal systems where you have an estuary or saltwater, we focus on nitrogen. Around freshwater systems, you focus on phosphorus. It does not mean you only have phosphorus in freshwater systems and you only have nitrogen in saltwater systems. They can be in both. They can be a problem in both, right? But that's how the conversation sort of breaks down. So some of the sources of nitrogen I mentioned, right? And I'll focus in on nitrogen as we, segue here to talk about the Rich Earth Institute's work. So some of the sources of nitrogen, specifically wastewater treatment facilities, which is coming from us, right? Eating and using our bathrooms. Septic systems, as you get further up into Vermont and New Hampshire, there's much less sort of wastewater treatment facilities handling our septage, and it's handled on site. And so that stuff leaches into the ground, can leach into the groundwater table, or can run off and then enter our rivers, is a big source. Atmospheric deposition, as I said, and erosion, right? So even stormwater, things taking, the water, taking things off the street and entering into our storm drains, gets into our rivers. And then agricultural inputs on farms, and then the erosion of soil on farms. So both phosphorus adheres to soil, and both phosphorus and nitrogen are added as fertilizers on soil. And so when it rains, the stuff runs off into our rivers if we don't have proper things in place. And then manure spreading, direct, just like our sewage, the manure that comes from animals, as that's applied to the land, or animals are just grazing, manure can also find, and nitrogen from manure can find its way into our waterways. Some of the solutions, right? So these are some of the things that we try to address and we try to implement. Green infrastructure, right? So what you have here is a picture of a pervious pavement, one of the many stormwater best management practices or stormwater solutions. In this scenario, when it rains, the water infiltrates. So you're not having it pick up things and then go to a storm drain and enter our rivers. So this is low impact development, green infrastructure, things like that is a solution. Another great solution that as an organization we do a lot are installing riparian buffers on farm fields and big fields, right? So when you have trees planted next to a river, you create a buffer where when the water runs off, it's more apt to get infiltrated and taken up by the tree roots, which is where you want that nitrogen and phosphorus to go to build those trees and help fight climate change, As I said, wastewater treatment facilities can be a solution because they can upgrade to capture more nitrogen, so less goes out the pipe into the rivers. And this is one of the regulatory requirements that has been occurring up and down the Connecticut River watershed in response to that EPA TMDL for the Long Island Sound. So making a lot of progress on this. but are finding the next step is addressing non-point sources. So the stuff that runs off the land. Another great solution is agricultural BMPs. This is a gravel spreader manure system, so that when this barn gets washed out, this actually infiltrates here on site, gets back into the soil instead of running off into our rivers. And then another great solution, which I'll pass over to Julia here, is this idea of pea cycling, being more responsible and figuring out systems for us to capture our own nitrogen and keep it from entering the waste stream. And so with that, I'll pass it over to Julia. And thanks so much for joining us, Julia.
Great. Yeah, thanks so much to the CRC for having me here today. So yeah, I'm going to kind of zoom in on that one aspect of nutrient pollution that comes from the wastewater stream, and tell you a little bit about what we do at Rich Earth Institute on the community scale here in Brattleboro, and then how you can do this in your own home garden anywhere, wherever you are. All right, so next slide. See here. So just to sort of recap, both wastewater treatment plants and septic systems, of course, were designed to primarily remove pathogens and organic matter from the waste stream, and are often quite effective at that, but they weren't designed to remove the nutrients that are contained in our human waste, and also the pharmaceuticals and other contaminants that get mixed in from industrial processes. And so especially here in Vermont, where we have a lot of septic systems, actually about 55% of the state is on septic. It's one of the larger contributors to that downstream nutrient pollution. You can see on these are kind of maps of our local watershed here in southern Vermont. And so you can see, compared to agriculture and urban runoff, septic system nutrient pollution is actually one of the largest contributors to pollution through the Connecticut River to the Long Island Sound. So that's kind of why we're really focused on wastewater as one of those sources in our watershed. And on that note, Rich Earth is actually one of the northernmost funded projects as part of the Long Island Sound Futures Fund, which is all about preventing that nutrient pollution. So even way up here in Brattleboro, Vermont, we're contributing to mitigating that problem downstream. Next slide. So yeah, as Kathy said earlier, those nutrients in our human waste travel downstream and contribute to that nutrient pollution that has all kinds of negative ecological effects on those downstream aquatic species. Next slide. So we kind of visualize this whole thing as a broken cycle, where on the one hand, we're capturing that nitrogen from the air in these really energy intensive processes to produce synthetic nitrogen fertilizer, which some studies estimate contributes about 2% to total global carbon emissions, just to convert that air nitrogen into plant available nitrogen through the Haber-Bosch process. So then we use those nutrients to grow our food, which we then eat, and then we flush those nutrients away into clean potable water. And so that's another problem with the linear flow, is we're wasting about 960 billion gallons of clean water every year in the United States just to flush urine alone. And so then once all of that urine is in the wastewater, it then has to be treated to remove those pathogens through wastewater treatment plants, which itself is also an energy intensive process and contributes about 3 to 5% to global carbon emissions. So the whole thing is very carbon intensive and wasting these precious nutrients that our plants need to thrive. And you may also have heard lately the kind of global crises going on around fertilizer shortages and price hikes related to kind of energy prices, where it's increasingly becoming a global problem of not having enough fertilizer that's affordable for farms. And so then all of those nutrients that were, very labor intensively, very energy intensively captured from the air get flushed away and pollute these downstream water bodies. So if you go to the next slide, here at Rich Earth Institute and at other circular sanitation organizations and groups around the world, we, instead of flushing away those nutrients, can reclaim them to fertilize our local farms and support local food cycles. And this not only prevents that downstream nutrient pollution, but also supports local agriculture in kind of a local nutrient sovereignty sort of way. Next slide. So I just like to share the fact that every day, and this is actually something we've calculated based on all the data at Rich Earth, that our bodies produce enough fertilizer every day to grow the wheat to bake one loaf of bread. And I think this is a good kind of visualization of the like potential for reciprocity between our bodies and the land, where, you know, the land can feed us what we need to eat in a day, and then we can give back to the land what the crops need to grow food. And we can just kind of keep that going in perpetuity. Next slide. So just to kind of demonstrate why we're focused specifically on urine at the Rich Earth Institute, you can see on the far left that urine is a very tiny sliver of the total volume that makes up what is wastewater, but it contains a vast majority of the nitrogen and the phosphorus. So just the sort of relatively small act volume-wise of diverting urine at the source is going to have a big impact on that downstream nutrient pollution. And especially we're focused on nitrogen because, as Kathy was saying, with the Long Island Sound being a saltwater ecosystem that's nitrogen limited, that is our kind of pollution of focus here in Brattleboro. But you can see on the far right that urine also does contain about half of the micropollutants, and that's in the form of pharmaceuticals. So in the next couple of slides, I'll just tell you a little bit about some of our research on that side of things when thinking about using urine as a fertilizer. Next slide. So on the left, you can see in the kind of conventional linear system, when we flush our urine, a lot of those pharmaceuticals pass straight through wastewater treatment plants and septic systems and aren't really broken down much at all. And what happens to them then is, along with the nutrients accumulating in the Long Island Sound or whatever watershed you're in, pharmaceuticals also accumulate. So whatever people are taking, caffeine, antidepressants, there have been all sorts of studies about how these are flowing through and accumulating in downstream aquatic ecosystems and having all sorts of bizarre effects on the species that live there, changing behaviors and causing all sorts of problems. The alternative to that is with what we do at Rich Earth, reclaiming it as a fertilizer, seems to be a better approach where, you know, instead of accumulating in these very sensitive aquatic ecosystems, there's a potential for it to be broken down in the soil in the way that there isn't in wastewater treatment. But of course, this raises new questions about whether or not pharmaceuticals are potentially accumulating in the edible crops that we're fertilizing. So if you go to the next slide, Rich Earth has been doing research on this very question for the past 6 years in partnership with the University of Michigan and the University of Buffalo and the Hampton Roads Sanitation District, looking at exactly what happens to those pharmaceuticals in urine when applied to soil and crops. And what we found basically is that a small proportion of it does filter through to the groundwater, which is what happens anyways with a septic system. And then some of it is present in the soil as well. But it appears that actually what we think is happening is the soil microbes are breaking down the pharmaceuticals, because when we sampled the crop tissue, it was present at just like very barely detectable levels. So our kind of way of communicating how the smallness of the pharmaceuticals that were detectable is that you'd have to eat a pound of urine fertilized lettuce every day for 2,000 years to get the same amount of caffeine that's in a cup of coffee. So it's kind of at this tiny level that's comparable to all of the other kind of contaminants that we eat living in a contaminated world where, you know, cows that take antibiotics make manure that's then spread on fields that then grows crops that we eat in the store. And whatnot. But so this is an ongoing kind of field of research. And there are also kind of additional treatment options to filter the urine further and get the pharmaceuticals out. But this is kind of the promising result that's inspired us to kind of continue with our approach rather than flushing our pharmaceuticals into sensitive aquatic ecosystems. Next slide. So I'm just going to tell you a little bit about the kind of 2 scales of pea cycling that we have going, and kind of what we're doing on the community scale here in Brattleboro, and then how you can do this at home in your own home garden. Next slide. So Rich Earth Institute in Brattleboro, Vermont has been in existence for about a decade now, reclaiming urine as a fertilizer on the community scale to to save the Long Island Sound from nutrient pollution and do what we can. So we have about 200 urine donors in our community who contribute their nutrients to our project. And they're all motivated by the kind of different factors I was talking about with the problems of that linear cycle, whether it's the water conservation benefit of urine recycling or helping to prevent that downstream pollution in the Long Island Sound. And also being able to just support local farms in this kind of sustainable way and sort of feel like you're supporting the local food system with your own bodily nutrients is pretty cool. And so this is both a demonstration project that we have going to show that this is possible, but really it's also a platform for research that we're doing both on sort of best practices for agricultural application, technology for better collecting and reclaiming urine, and also social research about the different perspectives different people have. So just quickly to answer your question, it's 200 individual donors, so less than that in terms of households. And some of those donors are people who, as I'll show you, I think in some of the upcoming slides, maybe go to the next one. Yeah, some of those donors are people who have these, we call it the Cubian funnel system. That's sort of a standalone urinal. That's a jug that they then bring to our depot. And some of those donors are people who actually have plumbed fixtures in their households with these special kinds of urine diverting toilets. That can either be on the top is an example of a urine diverting toilet that connects to a septic or wastewater system. So it's a divided bowl where the back half kind of flushes to whatever system you're connected to, and the front half diverts the urine into a tank that we would then pump out from someone's home. Or you can have a similar system that's a composting toilet. So you can kind of reclaim both halves of the equation that way. Next slide. So just a note about odor for the people using our more kind of informal collection unit is that by adding white vinegar to the jug and having a ping pong ball that sits in the funnel to prevent any air from escaping, we found that they don't smell at all in home bathrooms pretty much. So it's a pretty pleasant user experience for folks who contribute in this way. And also it helps to prevent the ammonia volatilization from happening, which is something I'll talk about later. But because the form of nitrogen in urine is highly susceptible to escaping into the air, anytime that you're smelling your urine, you're actually smelling it losing its fertilizer value. So it's kind of doubly beneficial to prevent any smells from escaping. Next slide. So the people with those jugs bring them to our centralized depot, which is in downtown Brattleboro. Next slide. And this has a vacuum pump out system, so you don't ever have to worry about coming in contact with the urine. The hose just inserts directly into your funnel and pumps out the urine that way. And then you have a clean jug to take home to continue collecting. And we have a little friendly piss-off competition that we do every year for donors to see who can be the most prolific contributor to preventing nutrient pollution in the Sound. We give off our special golden award for the winner and have all sorts of fun about that. And then next slide shows for those people who have actually toilet installations in their homes to divert the urine. That urine collects in tanks in their basement. And then with our special truck, we come and just pump it out a couple of times a year. So just like you might think about getting oil delivered to your house, you can get urine pumped out from your house and brought to local farms that way. Next slide. So then we bring it all back to our research center and we treat it. We use a high energy efficiency pasteurizer because while urine is largely pathogen free, it's actually in the olden days was actually kind of used as an antiseptic in some cases, but so urine is largely pathogen free, but there's a potential for, if someone has an illness or if through one of those urine diverting toilets, there was some fecal contamination that happened, just to be extra safe, we pasteurize it at the community scale. And this is certified by the state of Vermont, where actually we follow the rules to be a Class A exceptional quality biosolid. So then our fertilizer can be used on any local farm. But our state regulators also recognize that, urine is distinct from biosolids and that biosolids are a kind of byproduct of wastewater treatment plants. So they have, manufacturing wastes and all sorts of other things mixed in with them in a way that urine doesn't. When it's separated at the source, urine is a lot lower in all sorts of contaminants and doesn't have the kind of heavy metals that you might find in biosolids. And so on this point, we are also working on kind of nationwide regulation to help create a streamlined pathway for reclaiming urine as a resource so that it doesn't have to be treated as a biosolid, but can be treated as a unique substance that can be more easily reclaimed for local farms. Next slide. So then once we have treated the urine, we bring it to local farms to apply on their farmland. And every year, well, in 2021, we had our greatest collection year ever. We got 12,000 gallons of urine, which is about 600 pounds of nitrogen diverted from the sound, I believe. And then that fertilizer is then available for use for, we have several different local farms. We work with both hay farmers, like you can see in this picture. This is Jay Bailey applying with his draft horses to his farm. And we've also been lately experimenting with other kinds of farms for application, including folks growing hemp, corn, sweet corn, cut flowers, and fig trees was another one we were working on. So we have funding from the USDA to do these kind of trials, working with different farmers to experiment using urine as a fertilizer in different contexts. And this is also something that other folks around the world are researching about. And demonstrating that urine, when used properly as a fertilizer, has the same effect as synthetic fertilizers on increasing yield growth. Next slide. Oh, and yes, this is a demonstration of one of those kind of early yield trials we did, which demonstrates that diluted urine has a statistically similar effect as using synthetic fertilizer to grow hay. And so the strip of hay you're looking at down the center here is the urine fertilized hay. What you can see is much greener than the strip next to it, which is unfertilized control group of kind of yellowy looking hay grass. And so ever since then, all of the farmers we've been working with have been reporting just sort of qualitatively and also some different kind of quantitative trials we've done on increasing their yield. And we now have a greater demand from our local farmers for urine fertilizer than we can currently supply. So we're really focused on ramping up our nutrient collection, both from the nutrient pollution perspective and also to meet our local farmer desire for our ecological fertilizer. Next slide. So this is a kind of full breakdown of all of the nutrients that are in urine. So as I said earlier, urine contains a lot of nitrogen and phosphorus, and it also contains potassium. But beyond that, it has all these other kind of micronutrients that plants also need for growth in a way that synthetic fertilizer that you buy at the store might not. So we kind of think of it as a complete fertilizer in that way. While these nutrients are present in a small quantity, some plants only need them in a small amount. And if you kind of think about your diet gives you all you need to eat and to thrive as a human, and then if you give those nutrients back to the plants, it can give them what they need to thrive as plants, and so on. Next slide. So now I'll just sort of tell you a little bit about at the home garden scale, how you can do this in your own home garden anywhere if you don't happen to be in the Brattleboro area or have a community collection program right where you are. Before I do that, though, one other thing I wanted to say about the kind of community larger scale side of things is that in addition to this kind of community depot collection program, we also have a spinoff, actually business LLC called Rich Earth Tools that's focusing on scaling up that building collection side that I was talking about earlier, whether with urine diverting toilets or other kinds of toilets, where in addition to a large urine tank that could be in the basement of an apartment building, you could also have treatment and processing right on site, so that say a large green building, apartment building could collect all of the urine from the building, have it pasteurized and potentially even concentrated. And then the building just is a little fertilizer production factory for local farms or urban gardens. So that's another area we're kind of focused on scaling up in the future, and already have sold 6 of our pasteurizers to local other organizations and universities that are interested in replicating this. So then way on the opposite scale of things, you can also collect your own urine and use it in your home garden, in your backyard. Next slide. As sort of few things to think about when using urine as a fertilizer is kind of the quantity and also the timing of application and how you apply it to be best used for the plants. So the Mpk analysis for urine is 0.6, 0.1, 0.2, which you can kind of go a few different routes for thinking about how much you want to apply to your plants. One route is to actually work with your local state extension service if you live in the US, and they can do soil tests so that you know exactly how many nutrients are already in your soil, and then how much additional urine you might want to apply for which crops you're trying to grow. So especially you might want to use urine for heavy nitrogen feeder kind of crops like tomatoes, or other crops that need a lot of nitrogen, which is what urine primarily has. Our sort of general rule of thumb for applying urine is about 1 gallon of urine per 100 square feet every couple of weeks. But another way you can do this is just kind of actively looking for signs of nitrogen deficiency in your crops, like unusually slow growth or pale yellowy leaves. But one kind of point we like to reiterate is you definitely want to take care to not over apply the urine, because then it might run off into the watershed and contribute to that sort of nutrient pollution downstream. And it might also burn the crops that you're trying to fertilize. Like if you've ever seen a dog that pees in one spot consistently in a backyard and that spot is always yellow, that's the kind of thing we want to avoid happening. Next slide. When you're applying, the one other thing you might want to think about is whether or not you need to sanitize the urine yourself. So as I said earlier, urine is pretty much pathogen free. If you know yourself to be a healthy individual, it's safe to use in your home garden. But as an extra precaution, the World Health Organization recommends sanitizing the urine if you're going to share the produce with people outside of your household. And the way to do that at home is to just store it for 6 months at room temperature. But if you're just, growing your garden for your own family's harvest, you don't need to worry about sanitizing it. It's perfectly safe to use without going through that extra step. So then the thing you want to just keep in mind is that you're fertilizing your crops as they're actively growing. And this graphic on the right is a kind of good demonstration of when they're in their highest growth rate. In the sort of middle stage that's older than a seedling and younger than a flowering plant. If you have a plant that's already flowering and fruiting, the nitrogen will inspire more kind of leafy growth than fruit growth. So it's better to fertilize in that kind of middle window. And then applying in several small applications so that the plants are just getting the nutrients as they need them and not overwhelmed all at once and then hungry the next day. And it's also recommended to wait at least a month before harvesting any crops that you'll eat raw between when you fertilize and when you harvest, which I think typically is kind of what happens anyway with when the plant is ready to be harvested. But for example, lettuce, you should wait 30 days after you fertilize the lettuce before you harvest it, just to be extra precautious. Next slide. So the kind of main thing to keep in mind as a principle for using urine as a fertilizer is preventing this ammonia volatilization from happening. So the urea, which is the form that nitrogen is in urine, is highly susceptible to transforming into NH3 ammonia, where it's then lost into the atmosphere. So to prevent this from happening, it's best to apply the urine directly to the soil however you can. So that can either mean burying the urine with moist soil after application, like digging a small hole and covering it over that way. Or you can water your garden immediately after applying, or applying the urine just before it's about to rain. Or another way of doing this is actually diluting the urine before applying it to your garden. So mixing the urine with about 3 parts water or 5 parts water is another way to achieve this preventing of nitrogen loss. Next slide. So one kind of final note is that you can also combine your urine with compost. If you have a high carbon content compost heap, or compost source. The one thing urine doesn't have, of course, is the carbon that your garden needs, that organic matter. So especially if you have a lot of kind of straw or dead leaves in your compost pile, you can just kind of add urine straight into it and it'll kind of be absorbed like a sponge. But if you do have a lot of kind of green plant material or kitchen scraps in your compost pile, those have a lot of nitrogen in them already. So you can kind of think of that compost as being like a full sponge that doesn't have any extra capacity to absorb the nutrients in urine. So in that case, we don't recommend adding urine to a compost pile. Next slide. So the kind of final step of home gardening with urine that we recommend is completing our community science survey that we've sort of recently been launching to kind of grow the knowledge base about using urine in home gardens. Because while, as I said earlier, there's all this research going on about agricultural use of urine on the larger scale, there's not that much done on the kind of home garden scale that people could be doing in their backyards anywhere around the world. And there is a kind of, we know there's a lot of people who actually are already doing this in different places, in different contexts. And we'd love to kind of learn from your experiences and then be able to share that knowledge back with the community in our education programming. So I think you'll be sent a link to this if you are so inspired to contribute to this in the email afterwards. Next slide. So I'll just kind of end with a few tools and resources that might be useful for those interested in getting involved. One is we actually have these Cubian funnel urine collection units available for sale for $35 at our research center. And we also have them available for shipping worldwide. If you're interested in getting one of those, we've heard great feedback from our community members about this being a good way to collect urine in a source separated way. And there's also accoutrements that make it easy for people who typically stand to pee, who typically sit to pee, to collect into one of these units, including the pee style and also the toilet hat. And there's a tool called the solar dripper on the left that's a good way for then applying urine in small areas to a garden, which uses a bottle that screws into a little spout kind of cap that fits into the soil that we've found to be quite effective. Next slide. And just to conclude, these are some further resources you can check out if you want to learn more about this. On our website, we have a community scale guide for replicating what we've done here in Brattleboro on the community scale. And then we also have a home use guide for doing this in your home garden. And there's some other good books out there about using urine as a fertilizer, and also Pipe Dreams, which is a new book recently published about the kind of broader movement to rethink the toilet and our relationship to wastewater systems and ecological sanitation. And I think that's everything. Great.
Awesome. Thank you, Julia. And we will definitely follow up with an email for everyone who registered with some of the links to those resources and our contact information if there's more questions and stuff. We have some time now to answer some of the questions in the chat, and people can also speak up if there's additional questions. So I'm going to stop sharing my screen. There we go. And that way we can see each other. Feel free to turn your videos on, and we'll try to start tackling some of the questions that came up in the chat.
Yeah, I'm happy to shout out the questions. I'll try to do it in the order they came in and see what we can get to. This has been really informative. Thank you so much, Julia and Kathy. So Sandy asks about really how to get Rich Earth to come test their humanure at the Cobb Hill co-housing. So this might be a question other people who live in co-housing or maybe other scenarios. So they age their humanure 3 years before using it on our landscaping, but not on edible crops. This is because of fears about pharmaceuticals and other contaminants that could end up in our food. Can you speak to, you did speak to it a little bit as you went on, but can you talk more about, that question of the pharmaceutical issue and getting Rich Earth to come to different sites?
Yeah. So sort of what we found is that the pharmaceuticals that are present in human waste, which are a large part in the human urine side of things rather than in the feces, that they are broken down in the soil before the plants have a chance to uptake them. But it is something we're actively interested in researching. And also the whole question of PFAs, which is an increasing problem, especially with biosolids. So we know that, urine is present at kind of trace levels. I mean, PFAs are present at trace levels in urine, sort of just as a result of the fact that it's in 98% of the blood of humans around the world. And so we're interested in potentially doing PFA testing of urine in the future. And we'd love to talk with you about any way we can support your testing needs. One other thing I'll say on that topic is we actually recently got a grant to look at making biochar out of biosolids and other organic matter and combining that with urine. And one of the really interesting things about pyrolyzation to make biochar is that it actually reduces a lot of the contaminants that are in the waste stream, especially with like wastewater treatment plant biosolids, which are mixed in with all kinds of other contaminants from manufacturing processes. So what they found is that making biochar reduces 98% of the PFAs that are in biosolids. So that's also, an area we're interested in looking at in the future. But I can get in touch with you about what kind of testing needs you might be interested in. Yeah.
And just to remind folks too, that after later today, you'll get an email with lots of resources and links to the Rich Earth Institute. And I saw people asking, can you give us a checklist of all these steps or a copy of the slides? But I believe that will all be covered by the resources that Julia has shared with me to share with you. Since we do cover 4 states here, Julia, are there other comparable organizations like yours in some of the other states or any other states or countries for that matter?
Yeah, I think we're pretty much the only of our kind in the country so far. We have a vision of, replicating our community model in other areas and are actually launching our first replication still in Vermont, but about half an hour north in Bellows Falls. But there are other kind of co-housing or eco-village communities that reclaim urine on the kind of sort of smaller co-housing scale. Like Kailash Eco-Village out in Oregon has been doing a really amazing job of that for many years.
Great. Hope that more to come.
Yeah.
Abigail asks, what do you do to combat the stigma around using human waste as a fertilizer? That's a great question.
Yeah, absolutely. Well, I think the sort of like first thing I like to share about that is, the people say using urine as a fertilizer is a weird thing, but really the weird thing that we're doing is flushing our human waste into clean, potable water, which like when you think about it is totally absurd. But we do get that, there are all sorts of stigmas about human waste and people might have concerns. So actually, well, Tatiana is also here who's on our social research team. But we've done social research for many years about what different people think about using urine as a fertilizer. And one of the kind of biggest findings on this topic is that a lot of people, there's this concept called described attitudes, where a lot of people like say that they themselves think using urine as a fertilizer is a great idea and totally makes sense, but they worry about what their uncle or aunt might think about the matter. But then when you go and talk to their uncle or aunt, they're like, well, actually, my grandma did it, in the Depression because, that was the only fertilizer source they had. So we think that just sort of in general, promoting like people coming out in the open and talking about it and sharing their ideas and kind of this concept of cross-knowledge exchange where people from different perspectives can share their thoughts about it in a safe environment will increasingly kind of help bring it out into the open in a sort of joyful and celebratory way and not a shameful way.
Awesome. Is sodium a problem?
Yes, good question. So it really depends on what kind of environment you're living in. So here in the Northeast, because we're generally in a sort of wetter environment, the rate of transpiration from plants and let me take a step back. So if you live in an arid environment where there's not very much rain, then sodium can potentially be a problem because there's not enough sort of precipitation to wash the salt through your soil. But in places where you're irrigating enough or there's enough sort of general rainfall happening, the sodium in urine kind of trickles down through the soil and doesn't accumulate where your plants are growing. But it is something we're actively kind of thinking about, especially in contexts like hoop houses or greenhouses, where there is a potential for sodium buildup. But the sodium in urine is kind of comparable to other contexts that actually use reclaimed water from wastewater treatment plants that also has a high sodium content.
Great, thanks. I'm going to skip down to one that's kind of related. Is any concerns with using urine after intercourse or ejaculation, as long as we're on the topic of what's in your urine?
Not that I'm aware of. I think that would be a pretty small
Sure.
scale feature. We've also had questions about menstrual fluid and urine. And I think actually there's some, there hasn't been any kind of official research about this, but there's some kind of anecdotal thoughts that people have had that there might actually be beneficial microbes that can support the soil ecosystem in a way that maybe pure urine wouldn't. But I think generally if it comes out of your body and you're a healthy person, it should be fine for your garden.
Thanks. Are there any breweries involved as collection points? I think that's such a great question, as that is a high urine producing area.
Yeah, we're actually currently working on an installation at the Hermit Thrush Brewery in Brattleboro, so that you can drink your beer and then donate your beer to our program. There's also a big festival in Germany, I believe, the Pilsner Beer Festival, that for several years they had collection stations at the beer festival where they collected the urine from people, processed it, and then used it to grow the wheat to then make the beer again for the next year's festival. So absolutely.
I'll just add to that, Rich Earth Institute also has porta potties that I have seen often when I've been at, we have like outdoor brewery fest and our farmers market in Brattleboro. Rich Earth actually has like demonstration collection points there using porta potties.
And we have used them at some of our CRC events, and will again. Wonderful. Tomatoes need a fertilizer with 1:2 ratio of nitrogen phosphorus, higher phosphorus than nitrogen. Oh, I guess that's a comment. Did that align? I don't remember how the ratio that you had mentioned before was slightly different. This is just, that was more the average, and this is how tomatoes need it more.
Yeah, I think so. And just sort of, if you're using urine in conjunction with other organic composts for the tomatoes together, that should all kind of meet the nutrient needs of the tomatoes. We actually have a friend in France who designed that solar dripper I showed on an earlier slide, who does a lot of urine fertilizing of his tomatoes and has seen amazing results of increasing his tomato yield. And actually using a bricks I forgot the exact name, but like to measure the sugar content of the tomatoes, he found that just sort of in his own home garden experience, the urine fertilized tomatoes had a far higher sugar content than other tomatoes he was growing. So that's on tomatoes and urine fertilizer.
Great. Anyone experienced with using urine to break down wood chips from fallen trees to build soil? I'm testing this now, but would love input. From Jolene.
Yeah, well, we don't have experience ourselves with that exact question, but we have a partner or a friend organization out in New York called Compost for Good that has been doing a lot of work exploring using urine to accelerate the composting process. And they've designed this sort of large in-vessel composter that they combine. I believe they were using wood pellets and compost and human urine, and they found that the urine really accelerated the composting process that way. So there is some potential in that direction.
Great. Forgive me, but I'm skipping over the ones that ask about, can you share your presentation? Because we did say about that, and there'll be a lot of checklists and all that online. So if I miss anything, you'll also get Julia and Kathy's contacts as well if you want to follow up more specifically. And we just have about 4 more minutes left, but if anybody wants to stay on a little bit longer, the presenters are all willing to stay on another 5 or 10 minutes if you have a more particular question. Okay, so moving along. I'm curious about applications for boats, which often need to be pumped out if they have bathrooms on board.
Yeah, I think we have heard of some boats that do in-vessel kind of composting. There was actually one we heard about where they were using, this is kind of a different process than what we do, but they were using black soldier flies, which do some kind of process with the composting, but they had a whole system set up on the boat to do that. So there definitely are ecological boats that are exploring this. also. But yeah, we've heard like people suggest to us like cruise ships might be a good potential for this. We also a while ago were in contact with, well, national parks are another big area where this is a concern of, you know, they have to have these kind of privies out in the wild. Like Mount Washington was in contact with us because, you know, what they currently do with their waste is they have to have a helicopter come and like pluck it off the top of the mountain, which is a little absurd. Yeah, good suggestion.
There's a lot to be done to get this to big scale, isn't there? Coleridge asks about education to middle and high school students, and I know you do some of that. How can people get one of your presentations in their own communities?
Yeah, if you contact me, I'm happy to come Zoom into a classroom. We've been working with some local schools in our kind of southern Vermont region, but yeah, I'm happy to do that. We have kind of education programming tailored to different ages, so I'd love to talk with you about that.
Okay. Genevieve asks about something she read on a website about being on hormone replacement therapy. Is there any particular concerns about hormones over other pharmaceuticals?
Yeah, so when they did the 6-year research trial, they added some hormones as kind of, well, the range of pharmaceuticals they looked at were meant to kind of demonstrate the broad range of pharmaceuticals that are present in a community. And they included some hormones in that study. And I believe, what they found with the hormones was similar to the rest of the pharmaceuticals, in that it wasn't a sort of human health risk, the amount that was kind of barely detectable in the crop tissue. And I think the sort of bigger concern is, you know, currently there's a lot of research about what hormones are doing in downstream aquatic ecosystems in terms of the negative effects on fish and other aquatic species. So but good question.
Great. Also, I'll just interject because I see Luis has a hand raised. Luis, do you want to, ask a particular question, or did you ask them in the chat?
Hi.
Hello.
Do you hear me?
Yes, please go right ahead.
Yes. Okay. Hi. Nice to meet you. I'm speaking from Lisboa, Portugal. Okay. I'm very interested on these subjects. Thank you for existing. I've already talked with you about the collecting device. Very expensive to bring it here from Canada. And I've made another question about mixing urine and bokashi leachate, because I have a small urban rooftop garden, and I'm collecting urine with 3 Terra devices. I don't know if you know them. They are in Germany, near me. And I also use Mpk and Mpk bokashi to ferment my veggie wastes. I'm vegetarian, and I'm trying to produce some fertilizer to my garden. And I would like to know, I read something about bokashi leachate that has very good amounts of phosphorus and potassium, and as urine has a very good amount of nitrogen. I would know if you know of some experience mixing it and fermenting it and adding it to biochar and doing good for your plants in homestead garden, urban gardens. I believe that this is a very good solution system for urban gardens and for city homes. I also have some worms in my, I don't know, cave, not cave, garage. Yes, can I say that? And I try to use these 3 3 solutions to fertilize my soil.
Yeah, that's
So
awesome.
mixing bokashi leachate with urine. Somebody doing that?
Yeah, I think we haven't done any research specifically on that. But one other thing you mentioned about fermentation is something we actually have an ongoing research trial, actually in this very lab where I'm sitting, looking at fermentation and urine, specifically bioacidification with a variety of other we have a whole kind of suite of recipes we've been trialing out of urine with and urine with different kinds of things, because fermenting it helps to prevent that ammonia volatilization thing as well. So that's kind of an ongoing area of research for us. And also the biochar and urine thing is another kind of ongoing area of research. So you hit on 2 of our kind of areas of intrigue. I don't know, Tatiana, I see you're here if you have anything to add.
No, I was just going to say what Julia said, but we have not done anything with the bokashi, but that's very interesting that you're doing that, and we'd be very interested to hear more. If you want to send us your results, your experiences, we definitely want to collect those. And as Julia mentioned, with the citizen science survey, that would be one way, or you could just write to us and let us know what you're doing. Be great.
I'm not a very science guy. I have a law degree. Okay.
That's okay. That's what we're just collecting.
And it's a bit chaotic. The first, I've made two tries. Okay, I'm going for another one this time. Bit
that's
more
fine. If you don't need to, okay. and if that's fine. However you want to. That's what
okay. I can send you pictures and my sensations of if it's working. I will be very glad to share my experiments with you. And okay, and if you going to send us emails, I can do that. Okay, very glad to do that. I think this can be a lot of fun.
Yeah,
okay.
I'm gonna, sorry, just interrupt and interject because I'm just trying to pay attention to the time here. So for anyone who wants to stay on and has more questions, Julia and I and Stacy are glad to stay on. We are a little bit after 1, and I know people are often doing this on their lunch hours and stuff. So just want to say thank you to everyone who attended, who needs to jump off. Feel free to jump off. And for those folks who have more questions or want to chat a little bit more, feel free to stay on.
Perfect. There was a question I'll throw out from Sherry about the use of human waste being practiced in poorer countries over time, and are there any lessons that we have learned or you have learned from that history?
Yeah, that's a great comment and question. Yeah, so there is this kind of long history of people using this, like for centuries in terms of just reclaiming human waste in general. But also there's some really amazing farmer to farmer education projects going on in a couple of different countries in Africa where, small scale farmers who don't have access to fertilizer can, reclaim their bodily nutrients as an affordable fertilizer in that way. And Niger, I think, is one of the greatest examples of this, where they have a farmer to farmer education program through this kind of multi-step structured organization that they have, where they've trained about, I believe, 3,000 farmers in Niger to use urine as a fertilizer, and done some social research about that as well. So if you want to know more about that, you can email me and I'll send you the research paper about it, but definitely a good point.
Great. And why don't people just go on and raise your hand if you want to ask a question, and we'll maybe take 1 or 2 more. And just eager to listen. That's fine too. Well, maybe that's an indication that it's time to close out, which is great. Thanks everybody again. I echo what Kathy said earlier. We're so grateful, Julia, to have you here today, and for everyone from joining us from near and far and so many different countries as well. So we'll continue to follow up via email, and I'll share phone numbers and contacts for Julia and Kathy. So thanks again. We look forward to seeing you at a future live stream. Bye for now.
Great. Thanks. Bye, everyone.
Bye all. And thanks so much to the CRC for having me as part of this. It was, yeah, really great. Thank you.